So, hello everybody. Thanks for coming to my talk. My name is Martin Janiczek. I can be found on Twitter and GitHub and everywhere using this tag. And I want to talk to you about, I want to share my experiences writing a game, New Ash World, using the slightly unconventional language choice of Elm on both client and the server. What I'm going to do in this talk, well, first of all, let me give you the link to the game. If you have your laptops ready, feel free to open them. You can help me in later interactive part of the talk. Also, anybody watching the stream. So what I'm going to do is I will first introduce the game a little, give you some context as to why I'm writing it and so on. Then I will let you play the game a little bit in a little bit sped up format. So it's a tick-based game. Usually you get one tick every hour. So it's kind of this long-paced game played over days and weeks and months. So I'm instead going to give you a tick every second. So it's going to be a little bit more sped up. You will be able to experience in minutes what usually takes days and weeks. And then I will actually discuss some technical stuff, like the language choice, what were the problems with it, how did I solve that, what is that weird lambda thing you see in the URL, how the game works under the hood, and just generally I'm going to share experiences, like the good, the bad, and the ugly from development. All right, so New Ash World. In the talk title, I said it's MMORPG, but I guess the more precise term is PBBG, which is persistent browser-based game. And I think those games had their days of glory in 10 years ago and 15 years ago. But yeah, it's relatively easy to do. There's not much graphics you need to create and so on. Yeah, so it's mostly text-based, web-based, and it's multiplayer. So the game is set in the fictional universe of Fallout 2, which is an old game from 2000s, and it's basically post-apocalyptic RPG, again turn-based, and yeah, so that's a game I grew up on. It has I have very high nostalgia feelings for that game, and so it's set in this world after World War III, where everybody sent nukes on everybody else, and so the civilization is destroyed. Only small settlements survive. There is some technology left, but the knowledge how to work with it or how to repair it, create a new one, has been lost, and so people are figuring out agriculture and just trying to survive. So that's the vibe of the game. And so the reason why I chose to, I guess, reuse that world, there are 3 reasons for it. First one is I just like the game, and it is very interesting to me to think about if we took this single-player world, this setting, into a multiplayer, what could we do with it? Right? So could we, I don't know, create gangs? Could we create trade caravans? Could there be some social mechanics emerging from that? So yeah, it is interesting for me to see where that could lead, and it's in a way paying homage to the old game. I don't know why my slides are not working. Okay, and so second reason is if I reuse content from that other game, it lets me work on the more interesting part of the game sooner. I have this thing with my side projects where my attention span usually holds about like 2 weeks. So if I start writing some, I don't know, new kind of open source library, I know I have to finish it in 2 weeks, or I will, see some new shiny thing and start working on that instead of finishing this project. So I know I'm on this kind of roulette wheel. And so if I spend all my time writing dialogues and drawing some graphics, it will take away from my time on actually doing some interesting stuff like programming. So it helps me get to the interesting stuff faster. And third reason is I have actually played the game that I want to write. In the past, there was a PUBG game based on Fallout, and it was huge fun. So given my game is called New Ash World, can you guess what the old game was called? It was Ash World. So so it was a game by some Polish developer that I don't remember the name of, and there are big, or at least to me, big Fallout communities in Czech Republic and in Poland, and these guys are doing like LARPs, Fallout LARPs, and so on. They are crazy, but when this game came, everybody was just, yeah, let's play that. It takes like 5 minutes a day. So everybody, they ganged up. So Czech Republic was one gang, Poland was the other gang, and they just duked it out, and it was very fun. And suddenly, the developer's hard drive crashed, and they didn't have any backup, and there was no GitHub back then, and so the game just disappeared overnight. And I think the developer said they wanted to rewrite it, but they never did, which is understandable to me. With my attention span, I wouldn't manage to do that either, probably. So I know from experience, or at least maybe that's nostalgia clouding my judgment, but it was very fun back then. So I want to recreate that. Right. So now let me actually create the fast world for you. Now, am I in the right screen? Yeah. So now we will see a bit of my admin area. Okay, so let's create NDC Oslo. It's going to be a fast world, and now you should be able to create a character. So if I walk you through the process, register, this is the part where you can do it too. I'm just gonna pick some things here. Doesn't matter much. And I have my character, so now you will be able to, walk around the map, buy stuff from the vendors, fight other people, and if you go outside a town, you can actually go kill some NPCs, hopefully, if it works. So feel free to explore the game. And so, there are, let me switch to the talk again. There are, I guess, 3 main mechanics there. So fighting players, you can be, it doesn't matter where on the map you are, you will always be able to fight other players if you are both alive at that moment, and if you have the tick to spend on it. You can fight NPCs, you can trade with vendors for some stuff that isn't available somewhere else. So let me check if somebody actually managed to create. Seems like there are people. That's great. Yeah. Yep. So something is happening. It should be possible to see people moving. Thank you for participation. I will let this play out, and at the end we can have some like high scores, and I don't have any like stickers or t-shirts or anything, but you can have eternal glory in the YouTube video. So yeah, so have fun. Okay, so now let me actually talk about the technical stuff. So, you know, you are starting a full stack project, so you have to decide what to do on the web, what to do on the server. And for me, the front-end choice is pretty clear. I am a huge fan of the Elm language. I am writing Elm full-time, which is a dream job. At a company called GWI, we are hiring if you're interested. I just love writing Elm. And I think for a project of this, I guess, complexity, it's a very good choice, because Elm's strong suite is data modeling, meaning I can shape very clearly how, like, in what shape my data can be, and in what states my application can be. And that's due to some types, which are like the secret sauce behind this. And it's a feature that is gaining some traction, I think, as functional programming slowly also gains traction. But many languages don't have it, and I think that's a shame. It's really great when combined with stuff like exhaustiveness checking and so on. So to introduce it, if you are, for example, like a C# developer, it's basically enums with payloads. So, you know, your player can be logged in as admin, and then they have some kind of data associated with that. They can be a player, or they can be not logged in at all, and they don't see any of those other like fields. They cannot even like try to get at them. So this is in close relation. They are sometimes called algebraic data types, and they are related to, if I call them sum types, they are related to product types. And product types are just like records. You know, you have some fields and you have them all at once. So we have name and XP and hit points, right? On the other hand, if you have a value of the logged in type, you have either admin, or you have a player, or you have, you know, not logged in. And this combined with some other like ergonomics things that Elm gives us, this is just, I think is the one most important thing to give us like refactorability and maintainability. Yeah, so Elm has really spoiled me in this way. I probably wouldn't enjoy anymore like working in a language that doesn't have those. So F# is still in the game. F# has them. You know, Haskell, Rust has them. I think Kotlin and Scala kinda can emulate them with like sealed classes. But yeah, not many languages do have them. I wish more did. Yeah, so Elm on the front end, that was pretty clear. On the other hand, what to do on the back end? So, you know, there are languages like F#, Haskell, and so on that are kind of related, and that I would probably manage to work in. There are also languages like Elixir that would probably be better for like the MMORPG kind of stuff, and like having an actor for each player and so on. But I didn't like work with any of these very much before that, and I didn't want this project to become just like learning project to learn a new technology, because I already have advent of code for learning the new languages, so it's kind of a waste of time to be slower when I want to write this game, when I don't actually like do something just to learn a new stack. So yeah, so I was wondering, like, JavaScript goes out of the game because it just doesn't feel as nice to me as Elm does. And so after deliberation, I ended up with Elm. And it's not as clear choice as it might seem, because Elm is it's front-end focused language, right? So that's where it has its priorities. That's where it's nice to use. That's what all the package ecosystem, is built around. And there's not much focus on backend. So if you want to write a backend application, Elm compiles to JavaScript, so it's still possible. You can compile to JavaScript and run it with Node on the server. But you just have to write so much boilerplate. Because suddenly you have all these decisions like, what should I do for persistence, right? Should I save to a file? Should I use JavaScript local storage? Should I use some kind of SQL database? Right? Is SQLite okay? Should I use Postgres instead? Should I maybe try like GraphQL? This new kind of thing back then. And so it's all these decisions, like, should I what should I use for the transport of the data between backend and frontend? Should I use, JSON over HTTP? Should I try like protocol buffers or I don't know what, like gRPC? All the decisions, right? And so I kinda, just picked some and started writing the glue code. And it's just slowly like, my attention span started running out because I wasn't doing any of the fun stuff. I was just doing the glue and like getting it up and running. And it wasn't very nice. I just put the project to ice after I think I lasted a month, and I just said, this isn't very nice. There must be a better way. But I didn't know what it was. If like learning servant, I think it's probably not very readable from back, but it was like, I have read something about like servant in Haskell. Maybe I should try that. But yeah, I didn't do that. So I just put the project to ice. And then 2019 happened, Elm Europe conference happened, and there was this guy called Mario Rogic, who started the talk by saying how every time he wants to do some kind of side project, he has to decide on so many things, like what should he use for the transport, what should he use for like the deserialization and serialization, what should he use for like persistence, querying the database, how should he deploy it, how should he serve the front end. And I was like having this deja vu moment, like I actually know what he's talking about. I have experienced this. And so I started nodding like crazy, and I think many people in the room did. And yeah, so Mario just talked about all the glue that was, like this accidental complexity, I guess. It isn't your like application code that you want to focus on, right? And then he presented his vision, where all of the glue would be gone, and you wouldn't need to think about like JSON decoders and encoders. You wouldn't have to figure out how, I don't know, reconnection with WebSocket works. It's just, everything would be solved for you. You could focus on the front-end application, the back-end application, and you could easily move data between those with 2 new types and like some functions to actually send those. And it would just figure out like how to decode, how to encode, how to send that, how to do it efficiently, maybe in a JSON, maybe some kind of binary format. And it sounded so good. And Mario even let us play with a demo. So he gave us a link. We opened some kind of application on our phones and laptops, and I think it was some voting game where you need to guess what the minority will be. And everything worked, right? So he had the results live on his, I guess, like admin view. We had our player view. Everything went well, even over crappy conference Wi-Fi. So that was great. And I was very impressed, and I just wanted to use that. And so I did. And it is awesome. And I think words cannot describe, or at least I cannot describe with words, how great it is. So let me try to convey that by showing you a demo of how adding a feature to the game works and what I need to do. So I will not tempt the demo gods anymore with there's already the game happening while I'm talking, so hopefully that still works. Hopefully the server didn't crash. I don't want to look. And so I will not be live coding. I will just show you a recording and try to talk over it. So let's say we want to add chat functionality. And that's another reason why I don't want to do a live demo, because I don't have the courage of the guy from yesterday who let everybody upload photos to his slides. So I don't want to risk that. So let's just have a recording. So if you want to write a chat, you can imagine that on the front end, you would have input where you can write your message, a send button, and I guess a list of the chat messages, right, from the backend. So here I am plugging that all up in the types first, so that the compiler can help me with error messages like, hey, now you need to figure it out here and here. So I have they are now not on the slides, but I have added 2 messages for the front-end state. So remember this new message and ask to actually send it to the server. Now we have this toBackend type where this is what actually goes over the wire to the server. So we are saying, okay, I want to send this message with the text. When the server does that, he will send another message back to the front end, or potentially everybody, here's chat, this is the list of the messages. And this is horrible, inefficient. They should probably just send the one message, but whatever. We will add some metadata to there, who sent it and when. And now I'm kind of going blind. I should have started the compiler earlier, but we are adding the fields to the model, right? So we need to remember the current state of the input, and we need to remember the messages to show them. Backend also needs to remember the messages. So we are adding the chat there too. And now we have our error messages, which I think of just to-do list, now figure out this and this. So there is some initialization. So I initialize to an empty list and empty string. And now it tells us, this is the exhaustiveness checking, right? So it tells us you added a new message, but I don't know how to handle it. So we are just gonna use a simple setter here. When sending a chat message, we will clear the input and send the stuff to the backend. So you could see lambda sent to backend. That's just how easy it is. And now the compiler tells us we need to handle what the backend sends back to us, right? So here's chat. We are just gonna save that in the model. Now some new messages, some new error messages from the compiler. So there was initialization. There's another initialization error. So easy so far. And now backend needs to figure out what to do with the front end, with the message from the front end. So, when we get it, we're just gonna append it to the list of messages in the chat field, and later we're gonna broadcast that to everybody. So now the error message is that you need to provide metadata, which we do. We don't know the player name yet, but I have this thing in the model called logged in players, which is basically when anybody connects and logs in, I remember their connection ID against their name. So we are trying to get that. So we are going to use the client ID, which we automatically get with every message. So we know who sent it to us. And if we can't find the logged in player there, it must be somebody who didn't log in yet. So they are anonymous in a sense. Now this is going to look like crap, but it's just a demo. So let's just write something there. This thing I have paused on is we need to do some analytics. So we need to send the message to some kind of server. I will get to that later in the talk. And compiler says we are done, but we have a to-do, right? So we are going to broadcast the new chat to everybody, which is, again, horribly inefficient, but it's a demo. And the last thing is we actually need to show the buttons, the input, the chat, right? We have it in the front-end model. Everything is plugged in to receive the new data, but we are not showing it anywhere. So here I am creating a chat view function that takes the data and just, again, shows it in some kind of way. I need to plug some messages into the input and the button, which are gonna come up shortly. And that should be it. I think after I finish with this chat view function, it should be working, right? So let's try it out with Lambda Live, which is local development. It simulates the backend in your browser, but everything works as if it was running elsewhere. So yeah, it seems it survived the round trip. We have, anonymous there. So let's try it in another browser window. And can you see the bug? We have started a new browser window with the game, but we don't see the history of the chat. It might be intentional, but in this case, I want to fix it. So what should we do? When somebody connects, the backend gets a message, and they can send him the data right away, right? To initialize the client. So we're just gonna send them one more message in addition to what's already there. So again, send to frontend their address or their connection ID. Simple as that. And now, let's see if we open the page again. We are getting the history. And if we try to, communicate between the windows, it goes through the backend, everything seems to work. So that's how it feels to write with Lambda, right? So it's still the two Elm applications, and I didn't need to figure out any, how do I serialize this new message to send it over the wire? How do I deserialize it on the other end? It's just automatic, and I love that. So that's how it feels. Now let's talk about some other stuff. So migrations. What should happen when you deploy a new version of the code? Should everybody just restart? Should the server drop the old data and start from scratch? What should happen? How Lambda solves this is, migrations don't need to be written every time, every deploy, because sometimes you just change, for example, the view code, right? But the types are compatible, data is still there in the same shape. So Lambda needs you to write migration files when your types change. And so you basically, it generates this file for you, and you have to decide, you have some functions like migrate backend model, and the type signature is like the old version of the data to the new version of the data, right? So you just need to transform it. And you can decide, okay, in this case, I cannot do it, just drop everything, or you can say, okay, here's the transformed version. And so this is done for backend model. It can be done for all the front-end models, so everybody's game in their browser can be updated while it runs, and they don't even like see any kind of flicker. So yeah, it just takes their current model, transforms it using your function, and then just continues. It can be also done for the messages that are in flight. So if frontend sends a message, it goes over the wire, but the backend didn't handle it yet, and you deploy at that exact moment, which probably will happen if you have, any kind of bigger traffic. You can also write migrations for your messages. And honestly, migrations are not fun to write. I guess it's the price you pay for removing all the other glue. This is the kind of glue that you need to write. But during development, you don't even particularly care about losing any data, right? Because it's just you on your local host, and your players, you have two players like test 1 and test 2, right? And you are trying stuff while working on something. So you don't really care if it just gets dropped. So on development, you are mostly fine. But what to do on production? I don't really want to write a huge migration function for my model if I just like add a field or something. So what I did was I introduced some useful glue back, right? So Mario Rogic with his Lambda, he destroyed all the glue, and I said, okay, this one was actually useful, so I'm gonna put it back. And the way I do that is I deserialized the backend model to a JSON file, and the admin can download it and restore it again. So that's kind of nice. That also allows me to, let's say I'm writing some code for like a level up screen, and let's say on level 3 you are getting some new perk or whatever. So it wouldn't be fun if I had to, like after every code change, the backend model reset, and I needed to create a player and mash the fight button so that he gets to the level 3, right? So it's nice that with these JSON backups, they are like plain text, right? So I can just give him the exact amount of XP he needs to just get to the 3rd level after one fight or whatever. So it's useful for development. And there's a problem though. What if you add some fields to the backend model and your JSON schema changes, right? If you add a new field and you are expecting it in the decoder, suddenly the old backup files will not work anymore. So I solved this with version decoders. So in my mind, decoders are immutable. I can only add new ones. And then I just try them like from the newest to the bottom. So if the newest decoder can parse the old backup, that's great. If not, I just try the little bit older one until I find one that works. And this works reasonably well. I think that's nice. Now, in the demo, you have seen I needed to write some JavaScript, I needed to write some JSON decoders for the message, and that's because I sent all the backend messages, all the messages going from frontend to backend. I send them to a service that remembers them. Because, again, Elm is not, it doesn't have all the bells and the whistles to be a backend language. Elm is a very constrained language, and basically on the server you have all the front-end tools you want, but you don't have like special backend tools. So what I have, what browser can do, and so what this backend, Elm backend can do is I can just send HTTP requests, right? So I am not connected to a database directly. I just send HTTP request and forget about it. And so for this, I created a small server with the Dark language. It was, I don't know if you know it, it has this like, it's very low code, I would say. And yeah, so I just created a database there, one endpoint to save it, one endpoint to get it, some API key authorization, so not everybody can like download the data and so on. And it took me like 10 minutes. It was nice. If they close shop, I will need to do it myself, I guess. So I guess I am a sucker for vendor lock-in with Lambda and with Dark. But yeah, it is solution. It didn't took very long time. I didn't have to figure out like how to spawn a server in Kubernetes or somewhere. So that's how I do analytics. Now, I spoke a little bit about how the connection is made. So it's not JSON over HTTP, it's WebSocket. So anytime somebody connects to the application, they get connected to the server, and all the reconnection stuff is handled for me. There is 0 WebSocket code in my repository. And again, Lambda generates an efficient binary format. I think it could be compared to like protocol buffers or something. But it's basically, it allows me to have any Elm type deserialized into whatever, and serialized to whatever, and deserialize it on the other side. So what actually flows through the WebSocket frames is very minimal. And yeah, I mentioned this in the demo, but that's basically how the applications talk to each other. So the 2 functions at the top are for the backend, so that it can remember some data about the new client and see that they have like closed the window or whatever. And then the 3 functions below are just how they talk to each other. And it's very like natural looking. So that's about WebSockets. Now, I don't know if you played with the game a little. There are fight strategies. So let me just quickly. Well, I guess I have screenshots. I basically created a programming language just for the game, and in there you can customize how your player is actually like fighting. You can make it more intelligent than just like run to the other guy and just bash him in the head. You can say, okay, if I am low on health, heal, eat something, and all that stuff. And I think it's a huge fun finding an excuse to create a DSL like for your project, either in work or at work or like inside project. I just loved, being able to spend time on like parsing some language, designing like the types, writing an interpreter. I think it's really natural in languages like Elm and F# and so on. With these sum types, it really can be modeled very nicely. So yeah, though I can't really expect everybody who plays the game to be a programmer. So I hope it's like natural enough, or like English sentence looking enough. I need to have like syntax reference, right? So that's where the players can see all the possible things they can write and influence. but it's not enough. And so I need to tell them what to do while they are writing it. So it's not just a plain text area. I need to give them some information, right? And Elm is known for its great error messages, and I think it's pretty neat that the Elm parser library has the same values, and that it tries to give you enough information for you giving nice error messages to the users. And so on the right, you can see I'm telling the user, hey, at this place, this is what I would expect next, right? So I'm not telling them, hey, your program doesn't, parse, doesn't compile, like fix your stuff. But I'm saying, okay, your strategy is not finished yet. You wrote like if, then, I need an else, right? And again, I don't have like a video demo of this, but I think it looks pretty nice when you just follow what it tells you and like pick from the next possibilities, right? So I need some kind of like less than operator. Which one of these do you want to use? And yeah, that's just nice. On the left, the caret, I'm just taking advantage of the fact that this is like monospaced font, so I can calculate like the pixel position of where I need to like show the yellow stuff. Right, so I don't know if I have enough time to actually go over how it works. I will try to do it quickly. So the program, like the string that they write, it parses into fight strategy, and it will later be used, with the interpreter, I guess. Strategy state is just like the state of the fight. So how much health do I have? How much health does he have? How far we are from each other. And it will run the user program and give back a comment. So comment is like actually what to do, right? What's the next action? So attack, heal, move, or something else. And so this will be run many, many times during the fight. So you can either have a comment right away, so just do something, or you can have an if. So if has a condition, and in each of the other, and each of the possibilities, it just recurses back to the fight strategy. So ifs can be nested, and so on. Conditions, or an and, this is how you combine them. Operator and the other stuff is just like actually checking some values in the fight state. One short aside, if you have two binary operators in your programming language, meaning in my case or an and, you suddenly have a load of problems because you need to solve precedents, right? If I do this and that or something else, like what do I do first? Do I first do the or do I first do the and, right? So it's ambiguous. And so normally you would have to use some kind of shunting guard algorithm or pred parsers, which are pretty awesome. At least like in the functional programming setting, I think they're a nice solution to this problem, pred parsers. But I cheated. I just made it part of the syntax that if somebody wants to use or and, they just have to provide a parenthesis, right? So I let the user solve it for me, and I think it's not so costly to them, and it's very much easier for me to parse it because I have the parenthesis. So type value, it's not a function, it's not some kind of like getter. It's just a piece of data that says my HP, my action points, distance, and you later have, again, function taking the current fight state and the value, and it gives you a number that you can then use with the operator, right? So I can check, is my HP less than 10, for example. So that's it. that's how it works. It's all pretty simple to write. So if you feel like you don't have what it takes to like write a DSL, think again. It's really simple. And I think in languages like F# and so on, it's going to be much simpler than, for example, in C#, probably. So go try that. And that's all I have. Let me see if everything went well in the game. So it seems like people are doing something. They are fighting. That's good. And so let me cut it short. And I'm going to screenshot this because it is probably a moving target. So the ultimate winner is Cracklin, which is my colleague from work. So hello, Tomáš. So he's not here. So nobody of you, you didn't win, but he did. And it seems there is one other guy that took a honorary place of buying a book from a shop. One secret, books don't do anything in the game yet. So why? But yeah, so are you actually here, Andri? Is that somebody from? Okay, so congratulations. All right, so that's the eternal glory part. And that's all I have. If you have questions, I will be glad to take them, but otherwise, thank you. So one question there.
It looks like it would be very easy to write a bot that just constantly beats up lower level players for infinite experience. Is that correct?
Okay, so the question is, it seems to be easy to write a bot that just bullies low-level players for experience. So I think that would be doable, yes. I think with something like Puppeteer or Cypress, you could write such a thing. It's probably a little bit harder than if this was like the server-rendered page instead of like JavaScript single-page application, because we don't necessarily like have, I don't know, like IDs on links or whatever. But yeah, it will be possible. There is some balancing in the game. So you are getting hit points, you are getting experience points based on how much health you take away from them. If you win, if you don't win, you don't get any experience. So if you try to fight somebody who has just been beaten up and has like 2 hit points, you are not going to get very much experience, and you are going to lose the tick, right? So it costs something, which I don't know how the game went in this fast setting, because getting a tick every second is kind of crazy, and also there is some like HP regeneration. So the curves and the balancing is probably thrown off. But in the normal game, where you get a tick every hour, it's very much slower. So you are actually prioritizing how to use your tick, right? Do I heal a lot? Do I move somewhere? Do I fight somebody? And do I fight a player and the risk that they are going to be stronger? Or do I go for NPC? Again, NPCs have, I think, less experience than players to give you. So yeah, there are these like balancing acts, and it's all, this is like game design question. How to make it not profitable to make this kind of bot that just picks on lower leveled players. But yeah, fair point. Okay, another?
You actually lose, okay, so when you lose a fight, you waste your ticks at least, but do you lose anything more than ticks, or do you only lose ticks from losing a fight?
So the question is, you lose a tick if you fight somebody. Do you lose a tick or something if you lose a fight? So you essentially like die, so your HP goes to 0, and if you damage the attacker, they keep their like HP after that. you, as a loser, only lose the HP, and I think there is some transfer of money, again, based on how much health you took away from them. So if somebody has like 1 million coins, but you kill them when they are 1 hit point from 100, you are just gonna get that portion, that percentage. But if you attack somebody and win when they are at full health, you just take everything from them, like all the money. They keep items, but they have 0 health and they give you all the money. Another question?
I have a question. So regarding architectural approach, was the code like they recommend officially, like put in one huge ass Elm file, or you kind of split it into multiple submodules and parent-children communication, etc.?
Right. Okay, so the question, just to repeat it, is architectural. How did I structure the Elm files? Did I just put everything in one file, or did I organize it into submodules? And so the way to do it in Lambda is you have like the types file that gets shared between frontend and backend, and you have frontend file and backend file instead of one main file. So in that sense, those two are split. But other than that, it's up to you how to organize one application and another. I think I ended up using like one single module, let's say, for most of the state. So I don't do very much of like parent-child communication. I do it in some screens, like the barter, like the trade screen in the town, because it just has lots of state, so I thought it would be better to just push that into its own file. And I also like organize the code around the data structures. So for example, the fight, like the log of what happened in the fight, like you came to them, they came to you, you started, you hit them for 3 hit points or whatever. This log has its own data structure in its own file. So it's like data.fight and so on. So I have a lot of these, like data.vendor, data.item, data.player, and so on. So not everything lives in one file, but yeah, I didn't really like for example, all my views live in one file. I don't have like page.trade, page.fight. I don't do that. I think the boilerplate would overweigh the benefits from that. Okay, any other question? So I think that's it. Feel free to ask me anything after the talk. And again, thank you.